briefly about the quiz. Number one, I really wanted to see similar triangles there. Congruent triangles just won't do it. Number two, I think everybody got 2, 3, and 4 right. How do you calculate the sine of an angle? Well, you take the length of the side opposite the angle and divide it by the length of the hypotenuse. And how do you calculate the cosine? The length of the leg adjacent to the angle divided by the hypotenuse. Tangent of the angle, the length of the opposite leg divided by the length of the adjacent leg. What's a radian? Yeah, I know you guys asked me about this last time too. Well, what I wrote down is slightly different from what I responded in class. Angle formed when arc cut off in unit circle is r in length. So in other words, the angle when the arc cut off on the unit circle is 1 radius. That angle formed is a radian. Is there another way to say that? Somehow you got to get in there that it's based on this arc length. I think it's got to come down to something similar to that. Questions? Anything that's, let me know if you don't think I graded it fairly or whatever, but more important right now is, do you get what I was asking about? Yeah. Number one, similar triangles. I don't know, I can't remember. What did you have? Okay. Anyway, the idea that if the two triangles are similar, that makes it possible because those create, you don't have to say this, but that creates these proportions. And that proportions, that's trig. So similar triangles is the thing in geometry that really makes it all happen. So if there weren't such a thing as similar triangles, you would be spared this part of the course. There would be no reason to have it. Yeah, my apologies. I guess a couple of the assignment questions, this is one of the dangers of teaching away from the book and then coming to the book, and I didn't study carefully. I guess I asked you about some functions I haven't talked to you about yet, and my apologies for that. I've only shown you 3 trig functions, and the assignment kind of assumed you knew all 6. And then some of the questions were based on that, like one of them they said, well, okay, so first of all, you could have done the other 2 instead of the other 5, but then 2 of them were cotangent and secant, and I hadn't shown you those. And so if that happens in the future, just realize that I goofed, and I'm not going to really ask you to do assignment questions. I didn't intend to ask you to do assignment questions that were not on what we had already covered. So, sorry I didn't do my homework enough on that. So that wasn't intended. Sorry about that. Do you want to go through any of the written assignment things? 19D. Oh, that's a secant problem.
So you don't know?
No. And that's not all. I'm not going to teach you this 90 minus thing. Yeah. I should not have given you that problem. The secant, by the way, is the reciprocal of the cosine. But in my way of teaching it, I like to get to that at a different time. If you look on the outline, you can see when I'm going to get to it. So the outline is kind of the outline for my trig book. Haha. But in effect, that's what it amounts to. Over the years, I've found the sequence that I'm presenting it to you in is the one that I have found really makes logical sense and progresses smoothly through. I just think it's a better progression. Assignment questions? Other than that one I shouldn't have given you? There's probably a bunch of those. Well, what was the big topic last time? I would say it was two special triangles. Tell me a little bit about the two special triangles. What are these two special triangles? How would you name them, first of all? Yeah. That isosceles right. Tell me a little bit about it. Yeah, it's got a right angle. And why? Yeah, and why are they both 45? Why are they both equal? I'm sorry, I'm pushing you pretty hard here. But it was something you've already said when you named it. How did you name it again? Yeah, and one of those words tells you why they're both equal. Isosceles. Because isosceles means two sides are of equal length. And if two sides are of equal length in geometry, doesn't that force the base angles to be equal? So it's because of the isosceles. Okay, and because two legs are equal, how did we wind up labeling that isosceles right triangle? We called the two equal legs 1, and then using the Pythagorean Theorem, what do you come up with for that hypotenuse? Square root 2. And therefore, once you know those, once you've got the triangle labeled, can't you rifle off the sine, the cosine, and the tangent in 45 degrees just by looking? Okay, what was the other special triangle? Somebody else. Yeah. Well, and that would, you might think, why did I pick that? It all has to do with a geometry theorem. What geometry theorem? Now this is a tough one, I admit it. I don't expect all of you to come up with this, but what's the geometry theorem that made that special? Anybody remember it? Way back in the annals of geometry. I'll just, yeah, I didn't expect you to come up with it, but it goes like this. In a right triangle, the side opposite 30-degree angle is 1/2 the hypotenuse. So in a right triangle, side opposite 30-degree angle is half the hypotenuse. And that's exactly how you set it up. You take the side opposite the 30-degree angle and you label it 1. And then you label the hypotenuse 2 based on that theorem. And then you have to find the remaining leg using the Pythagorean theorem. And what does that missing leg wind up being this time? Square root 3. Yep. And now, not only can you do the 3 functions of 30, you can also do the 3 functions of 60, can't you? Yeah, so in effect, we've now learned what? 3 special angles. 30, 45, and 60. They're special because they relate to these special geometry theorems. And really it's the foundation for, wow, I would probably say 70% of what follows is based on those 2 triangles. So you want to be able to really nail those triangles, right? Okay. I think we're due for a quiz. Okay, now I didn't write anything out, so I'm going to just pretty much write the quiz. I'd like you to fill out a chart. I will draw it up here. Made the chart way too big. Okay. Complete the chart. Now, what I mean is, fill in these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 boxes. And I do not want calculator answers, and in fact, you are not allowed to use one. You have no need of one. Sorry, can you guys read that? My pen is acting weird today. The top line reads RAD, short for radians. Then it says DEG, and then it says sine, cosine, tangent. You are welcome to draw triangles on this page and do things like Pythagorean Theorem work. Actually, that's highly encouraged. Please don't forget to put your name on there. So I drew a couple triangles up here. This is the isosceles right here. So these are both 45. So these two sides are of equal length. Side opposite the 30 is half the hypotenuse. I'm not, if you want, I can show you the Pythagorean theorems I used to get those. But anyway, based on that, what's the sine of 30 degrees? You can look over to this triangle and go, okay, leg opposite over hypotenuse. Sine of 45 degrees. Sine of 60 degrees. That's supposed to be a 3 there. Cosine of 30. Square root 3 over 2. Cosine of 45. Cosine of 60. Tangent 30. Tangent of 45. Tangent of 60. You could just say square root of 3 over 1 or square root of 3. Radians. I guess you could have calculated it, but anyway, that's what I was looking for in the quiz. Questions?
Yep. For the first, or the tangent of 30 degrees, does the square root could be the numerator. So could root 3 over 3 be the answer?
Yeah, you mean you rationalized it? I certainly can't fault you for that. Yeah, this is the way I prefer it, but I don't have a problem with that. He's saying, is it all right if I did more and I did it right? No. I mean, is that a problem? No. Is it all right? Oh, yeah. Okay, on we go. Trig 4. Oh, anybody else have a quiz question? Now, don't think you're done with this. Oh my, are you not done with this? This is going to keep coming up over and over and over again. So if you're having some problems here, let's get them right now, because this is going to keep coming back. Okay. Actually, it's going to come back. It's going to grow. And today we're going to do some growing with that. So here's kind of the agenda for today. What I call behavior charts. I started showing you the behavior charts last time. I think we went through the Sine behavior chart. I don't think we went through the cosine. Why did I call it the Sine? Because we're forever talking about the SIGN and the SINE, and they sound exactly the same. So, all right. I believe we did this last time, but let's quickly go through it again. This is what I call the SINE behavior chart. You can print this, so you don't have to draw this all out. You might have trouble seeing it. Hopefully that green isn't too much of a problem if you print that it doesn't come out. But anyway, I used 3 different colors for the 3, and maybe I shouldn't have picked this light lime green. But anyway, the idea here is the sine is this guy right here. It's this this right triangle we're drawing here. It's this leg opposite. Here's theta. The leg opposite is this guy. And that's why if you look here, I've labeled this sine. And as this angle rotates, this leg will change in height. When this angle goes down to 0 degrees, this thing here will collapse to nothing. As you go up with the angle, obviously this leg is going to get bigger and bigger, hence it's increasing. And in fact, if we get all the way up here, the triangle kind of collapses right here, but it's still this full height. And so then it would be, this leg would be 1 in height. So the sine of 90 degrees, or pi over 2, is 1. Then as we keep rotating, this leg is going to start going down. It's going to be this high, and this high, and this high, and so forth. And it's decreasing, and it's decreasing down to a complete collapse down to 0. When we move down below here, past 180 degrees or past pi radians, we consider everything below the x-axis as being negative, just like we do on normal graphs. So now this leg is going to be down here, and it's going to get bigger negatively. Well, when something gets bigger negatively, it's still decreasing, right? And it gets all the way down to this full length below the x-axis of 1, so -1. So therefore the sine of 3 pi over 2 radians for 270 degrees is -1. Still negative over here, but now it's getting negatively tinier. So it's increasing. Comes back to 0, and you could keep rotating, and the same cycle keeps repeating over and over and over again. So, what I see, I don't want you to memorize this chart. What I want you to memorize, hopefully what I'd like you to get in your brain up here somewhere, is this little video of this angle going like this. And you can actually watch, in your mind, you can watch that leg grow from 0 up to 1, then down to 0, and in the negative range, down to -1. You know what I mean? That if you can see that little thing in there, you know, hey, the SINE is positive, when it's above. So anywhere from 0 to pi radians up here, it's positive. It's increasing, and it's negative down here. It's increasing over here. It's decreasing over here. Still decreasing. Increasing. And if you can kind of see that little video up there, that's my idea of this. Because then one of the biggest difficulties as this chart grows bigger, that I had you do a quiz on today, when that chart grows bigger, probably one of the chief difficulties you're going to have is the SIGN. When is it positive, when is it negative? If you remember these behavior charts, you'll be able to nail that. So, if you're thinking sine is this guy, vertical coordinate, okay? Positive, positive, below, negative, negative. And if you can see that up there, you got your SIGN basically nailed. Okay? I don't know, does that make sense to you? I think I showed you a little animation last time too. Okay, now this is a better color to see. This is the cosine behavior chart. Now, probably the most important thing up here is, do you notice the sine was that vertical coordinate over here, this guy. The cosine is the leg adjacent over the hypotenuse. The hypotenuse is 1, right? So the leg adjacent over the hypotenuse, cosine over 1, which is cosine. So in other words, all you got to do is watch this horizontal leg to see what's happening with the cosine. Same, excuse me, same motion. We're still going to take a positive angle and we're going to spin around. But now, instead of watching this guy, we're watching this guy. And so, if you picture this blue cosine guy down here on the bottom, as this angle is down all the way to 0, isn't this cosine guy full width? And so, the cosine of 0 degrees is 1. If you can see that, it's going to make it so much easier to learn this. You know what I mean? Instead of, oh, I got to memorize that, the cosine of 0 is 1. No. I don't want you to do that. But if you can think of this as being the horizontal guy, you can just see it in your head. Cosine, full width, 1. Okay? Now, as this goes up, this triangle, what's going to happen to cosine? Isn't it going to be shrinking? So right off the bat, cosine is decreasing. Starts at 1, it's getting smaller, and we get up to here, cosine has, this horizontal coordinate has shrunk to 0. Hence, cosine of pi over 2 is 0. We keep going over here. Now, because we're doing horizontal guys, does it make sense to you that over here is positive and over there is negative? So now, because we're going left of the y-axis, and this is a horizontal guy we're studying, this is going to be negative over on this side. Instead of before, positive up here, negative down here. Now, it's a horizontal guy. Positive over here, negative over here. So you notice positive, positive, negative, negative. Okay. So what happens when we just get into the second quadrant? Well, cosine's going to be relatively small. It's going to be negative, and it's going to be getting negatively larger, which means it's decreasing. You know, as it's getting more negatives, it's going to be decreasing. And when you get to 180 or pi radians, it's full width, negative 1. We start moving down here, and this horizontal coordinate starts shrinking negatively, getting smaller, so it's actually increasing. Or if you want to think of it this way, increasing, this guy is whenever it's moving that way. And you see how it's moving to the right? Okay? And in fact, it shrinks down to nothing. So the cosine of 3 pi over 2 is 0. Now we start going back into the positive range again. Tiny, bigger, 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 full width, 1. And again, the process starts all over again. So, if you can just remember, this guy is sine, this guy is cosine. This stuff can all be kind of viewed graphically. And if you've got that graphic view up there, I just think it's a great way to learn what the trig functions do. Again, instead of memorizing about 40 things, we're just learning like one little mental video, if you will. Or I shouldn't say one, we're learning 3. One for each of the functions. Okay, does that make sense? And the third one is the tangent function. Tangent. Now, this could be a little confusing, because this too is a vertical guy, but instead of going the leg of the triangle like we did for sine, do you notice now I'm waiting until we get out to this line. This line, what do we call a line like this that just touches the circle in one point? I'll give you a hint, it's at the top of the page. It's a tangent line, yeah. And that, by the way, that's where they got the name, tangent. So there really is a link to geometry. So this line is tangent to the circle, and when this hypotenuse comes out and touches that tangent line, this height represents the length of the tangent function. Okay, so it's confusing because not too far away is the sine guy. But the sine guy stops at the circle. The tangent guy stops at the tangent line. So we've got to be careful there. So at 0, wouldn't you agree this is going to be down to nothing? So it makes sense that the tangent of 0 is 0. And as we move up, the tangent's going to get bigger, just like the sine did. It's going to be increasing. And because it's above the x-axis, it's certainly positive. Now, this guy's going to get huge. Can you see that? Now, I didn't have room here, but what if we had an angle, for example, I wish I had a long straight edge, but I don't. And what if we had an angle, let's say, more like this angle? Well, that's not going to hit the tangent line until about here. And so now the tangent's all the way from there to there. And so you see how the tangent is getting way above 1. In fact, it's going to get huge. In fact, can you imagine what happens when we get to like 89 degrees? This is going to go like this, and we'd have to go up about maybe 5 stories before it hits this line. And so the tangent's just going to get massive. In fact, take out your calculators. Let's just play with this a little bit. Go ahead and do the tangent of... Well, by the way, does it make sense? Where's 45 degrees? Before you do something on your calculators, there's one more little test. On your quiz today, what did you write for the tangent of 45 degrees? Well, that was the radians, right. But what was the ratio? 1, right? Okay, look, tangent of 45 degrees. 45-degree angle. Isn't that going to go right through this point here? How high is the tangent going to be at that point? Oh yeah, it's 1. The radius of the circle. That makes sense. See, this matches. Okay. Now, go ahead and type in tangent of 80 degrees. Just tell me what you get. Somebody just call it out. Just give me to the 10th. What is it? 5.7. Okay. Now, let's do 89 degrees. We're up to 57 already. All right? Now do the tangent of 89.9. What is it? 500?
573.
Yeah, 573. Now do the tangent of 89.9 and as many 9s as you can. Okay? You get scientific notation? Yeah. Okay, so this is getting huge. You can imagine why. You've got this vertical line over here that you're trying to meet, and this angle is getting closer and closer to being parallel to it, right? At 90 degrees, they're never going to touch, right? At 90 degrees, will these two guys ever touch? No. So what's the length? Infinite. Actually, we call it undefined. It's like something divided by 0. And you know that your calculator goes. In fact, go ahead and do it. Do tangent of 90. Probably says tilt. No, it doesn't say tilt, but the next thing to it, it goes, nyeh. It should say error or something, right? It doesn't give you that nasty sound. Okay. So suddenly we're in deep trouble at 90 degrees. But as soon as, now let me explain how this visualization works. What happens when you get into the second quadrant? Well, my tangent line's over there. How in the world am I going to meet it? And the answer is we take this hypotenuse and we back it up until it meets the tangent line. And because now it meets below, we now say the tangent is negative in the second quadrant. You see that? So, for the illustration to work, when you're over here, you have to back the hypotenuse up until it meets the same tangent line over here. And now the distance is from 0 down to wherever, and this is a below the 0, so it's a negative distance. So the tangent of a second quadrant angle is negative. Okay? And then as we get over here further and further, what's happening is this is becoming tinier and tinier negative. So it really is increasing. Finally, when we get to 0 again, I mean, well, not 0, but 180, we're back to nothing. And when we get down in the third quadrant, we back it up, and we're going to get a positive again. See that? So because you're probably thinking, so this is the key line over here. And when you're in a quadrant over on this side, you just take your hypotenuse and back it up until you meet that tangent line, and then you, oh yeah, it's positive again. Third quadrant tangent is positive, and it's getting bigger and bigger and bigger, and it gets up to this incredibly large number. And once again, I use the 3 letters UND to stand for undefined. Back over here, I don't need to back it up, but it's way down there, and so it's a really large negative number when you're in here. You know, this is put down, I don't know, down maybe even below the parking lot before it finally meets this line. And so from there down to there, it'd be negative a huge number. And but it's gradually getting shorter negatively, so it's increasing. Eventually comes to 0, and we start over again. So tangent is kind of unique. This is the first time we've run up against this undefined thing. Remember, tangent is what? The leg opposite divided by the leg adjacent. And what happens whenever you reach, when you get here, when this thing gets up to 90 degrees, the leg opposite is 1, the leg adjacent is 0. And 1 divided by 0 is, I can't calculate it, undefined. So it also is confirmed when you try just the normal ratios. You can't divide by 0, and that's why you get this undefined. So the tangent, when it gets to 90 degrees, literally vanishes. And in fact, what we have is a vertical asymptote. Yeah. So what I would really like you guys to do is get really good at being able to see these in your head. First of all, to understand them. And if you can visualize this little animation and know that when you're watching the sine, you're watching this guy, negative. And when you're watching the cosine, you're watching this guy.
now you're watching the left-right guy. And when you're watching tangent, that's a little bit harder. That's when it meets that tangent line over here. So, bigger, 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 huge, undefined. Negative huge. 0. Positive. Bigger, 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 undefined. Negative huge. Back to 0. And if you can, I don't know, if you can get to a point where you can actually see that going on, this is not going to be very hard. Okay. Well, based on that, guess what? Our chart just grew to this size. Now, I'm out of time, but now think about this. So you already know 30, 45, and 60, right? So for yesterday, you guys filled in this much, right? Actually, it didn't grow to this size. They're still not into these 3 guys. So it grew to this size. You know these guys right here. I was on the quiz. Don't we know these now? Sine of 0. Think of your behavior chart. Sine is this guy. 0 degrees, 0. Cosine of 0. This guy. Full length, 1. Tangent of 0. Supposed to meet that tangent line. It's no height. 0. So we've just added these. And what's 90 degrees? Sine of 90. Sine is this guy again. Full height at 1. Cosine of 90. Shrunk to nothing because at 90, cosine is nothing. Tangent of 90. Berserk, or otherwise defined as undefined. You don't use berserk. That's really what it is. It's like, yeah, I can't do it. Okay, well, we didn't quite get far enough today. Study, study, study. No written work. Study. And when you're done with that, do some study. Yeah, I haven't, that's what I mean. I didn't get to that. What it is, first of all, 120 is nothing more than a 60-degree angle, because that's how far 120 is from the x-axis. So the numerical answer is the sine of 120 is the same as the sine. All you got to do is check the SIGN. That's what we're going to next time. I didn't get done with that today.